Reset the environment.
Hi friends, I recently attended a robotics hackathon, the so-called embodied AI, the very trending topic in industry. My personal experience of last time I touched robotics was when I was in school. I majored in automation, where you have to write C++ code to control the hardware, and also you have to learn FPGA and circuits. So I was excited to see how things have changed in the hardware world since I graduated. The hackathon host provided basic hardwares, including the SO101 ARM that is compatible with Hugging Face lerobot API. And of course, they also encourage us to use the lerobot package. Lerobot is something new to me because when I was in school, I have to write C++ code and write PID algorithm. But lerobot is a Python package that allows you to control your hardware and have everything run in MacBook. In addition, it also supports training. So you can teleoperate and collect training data and use the robot to convert it to some Parquet files that the training model can digest. So originally, we want to build a painting robot. The plan was to divide this project into two steps. The first one is a planner module, which is a VLM model that takes an artwork, for example, Van Gogh, and convert it to a sequence of strokes. And the second part where we will train the robotic arm to execute on different types of strokes, such as a line, a circle, a dot, etc. That's actually a good complex task to get us motivated. But the reality is, first of all, the arm we had, it doesn't have the dexterity to actually draw with precision. And secondly, artwork like Van Gogh was too complex for a cheap BLM task to convert it to a sequence of strokes. So because of these two reasons, we pivot to a cookie gripping robot idea. Our approach was quite standard. We want to train a VLA model. This VLA's input has two parts. The first one is a camera input, the MP4 videos. The second one is the action sequence of the robotic arms. The output of this model will be the action sequence for the arm. So the more training data you have, the better your model will be. So our plan was to collect 50 episodes of training data. Our team had 3 people, and we 3 all repeatedly doing the manual work of using the lead arm to keep gripping the cookie. Super repetitive manual work for sure. And we finished the 50 episodes. And then we trained 2 models. The first one is the ACT model, and second one, we fine-tuned a Pi model. So the only difference is that with the ACT model, we trained it from scratch. And with fine-tuning, we were able to leverage the foundational VLA model trained by physical intelligence. The training is also easy. The training we also autopilot using cloud code to do it for us. And we literally see the loss keep going down. And we're excited to see the inference results of our VLA model. However, what actually happens is that when we inference a model and run with our robotic arm, the arm seems to be keep gripping in the same direction and doing the same thing. What a human can observe is that the arm is not aware of where is the cookie. So I ran an ablation test. I masked out the video input, and I found that the action sequence output is the same with video input and without video input. So that means our VLA model was not actually learning the video input. That was 2 hours away from the hackathon demo. So we actually don't have time to fix it. So we pivot to the VLM model. Eventually, we opt out the VLE model. We use still the 2 steps. The first one is the VLM model for object detection, and second step, the executor step. Instead of training a VLA model, we teleoperated the follower arm. We recorded a few actions for the robotic arm to pick up things from fixed positions. So, to summarize, we initially wanted to build a complex Van Gogh painting robotics arm. Then we pivot to the cookie gripping robot. And eventually, we opt out the VLA model because we were not able to have enough training data. And also the model was not learning the video input. The final path we chose was VLM model plus recording the pre-telescoped fixed positions. During the hackathon demo time, I thought they were the only team who didn't train a successful VLA model, but in fact, that most of the team were not able to train an accurate VLA model. Why? First of all, as I mentioned, the hackathon was only 2 or 3 days. We did not have enough time to collect enough training samples. And second is the denoising part, because a lot of teams like us didn't have experience of collect the right training data set. In our case, the video input, it actually requires the clean background. So there's a team who pay attention to always use a white background. They train a relatively better VLA. So we didn't win the hackathon, but I do learn a lot about what the hackathon is about. The most important thing in hackathon is to find an interesting idea. It is not about solving a technical problem. It is about finding the right problem. It's about leveraging existing technologies. So for example, in this hackathon, the successful winners, most of them are inferencing models rather than training the model themselves. And secondly, what I found is that the VLM model is actually more mature than VLA model. A lot of team inferencing the YOLO model, the object detection model that was published 10 years ago. But the controlling part is the harder part, even though they are able to do object detection. But it is hard to make the robotic arm or the drone to fly or arrive at the destination we want them to be. I think the gap there is about controlling the hardware. And lastly, remember I fine-tuned the Pi model using our training dataset. Even though with the power of foundational model like Pi 0, I was not able to fine-tune it fast enough for our hackathon project. That also means that the ChatGPT moment for robotics foundational model has not arrived yet. But what would happen when it arrives? I think there will be a lot of use case in inferencing and training and fine-tuning. So specifically, I think that means there will be more GPU demands. And secondly, there may be more demands for fine-tuning in local. Because if the cloud GPU is a scarce resource, then fine-tuning in MacBook, Apple's own GPU, would be actually a good alternative. But the ability of Apple GPU is something I haven't explored yet. And so, yeah, that's my experience of weekend hackathon in robotics, embodied AI. It is an exciting area where there are a lot of problems remain unsolved. So, exciting times.